All right, guys, part 2 of finding real zeros of polynomials. Part 2. Here we go. First thing is Descartes' rule of signs. We're trying to find zeros really out of nowhere. So any hint that we can get to what the zeros might be is helpful. And the rule of signs is one of those. When we read this, it's going to sound really confusing. So I'm going to read it and kind of go through it real quick. But the example on the next page, hopefully, or the next slide, will help explain it. Number one, the number of positive real zeros that a polynomial has is equal to the number of sign changes, this has variations in signs, or is less than this by an even whole number. So how many positive zeros a polynomial has is equal to the number of sign changes, or is less than that by an even whole number. So the number of negative real zeros is equal to the number of sign changes if you plug in negative x, or is less than that by an even whole number. All right, so confusing as all get out. But let me show you what it's talking about. It's really not that hard. This is hard to put in words. All right, it says use it. Rule of signs determine how many positive and negative real zeros this polynomial has. Okay, so first of all, the way you find how many positives it has is you count sign changes. It starts out positive, changes to negative right there. So it only has one sign change, which means it can only have one positive real zero, which is very helpful, by the way. I'm not being sarcastic when I say that. To do the negative ones, what I'm going to do is I'm going to plug in p of negative x, which really what that does is that changes the the signs on the odd exponents. So it makes that negative, it makes this one negative, makes this one positive. The constant's always constant, so it doesn't change. And the reason it changes the negative exponents is because if you raise a negative x to an even power, it changes to positive. If you raise a negative x to an odd power, it stays negative. So there's one sign change, 2, 3 sign changes. That means there's 3 negatives. Now here's the weird part. Or the rule said less than this by an even whole number. So what you do is you find the big number, like the 3, and you subtract 2 until you get down to 1 or 0. So it has either 3 or 1 negative. Both of those are helpful because that means I know I have to have one positive real, and I'm going to have at least one negative real one, and I might have 3 negative real ones. So that's how the rule of signs work. All right, upper and lower bounds. This is also very helpful. So you want to try things that are way too big or way too small. If you divide your polynomial by a factor, by a number, and the quotient and the remainder has no negatives, like when you do your synthetic, if you get all positives in the bottom down there for your result, that means that's an upper bound. There's no zero past that one that's greater than that one. Now, if you plug in something and your signs alternate at the bottom, like you get like plus, minus, or backwards, minus, plus, and zero counts however you need it to. It says, if you notice the words here says non-negative, which means 0 is okay. If the signs alternate, that means it's a lower bound. There cannot be a 0 less than that number that you plugged in. So that's helpful too. So if you plug in a positive number here, a big number, and you get all positives on the bottom, which is what this says. I should have said that. You got to plug in a positive. If it's a positive number, you get all positives down here, that's an upper bound. There's nothing greater than that. If you plug in a negative number and they alternate, there's nothing lower than this number right here to try. Okay, let me show you that one too. It says show that the real zeros lie between negative 3 and 2. So I'm going to plug the 2 in first. If I do the 2, I'm going to go 1, 0, don't forget that 0, negative 3, 2, negative 5. I get 1, 2, 2, 4, 1, I'm flying here, 2, 4, 8, 3. And see, all the numbers are positive, which means 2 is an upper bound. There's no 0 to this. There's not a solution or not a 0 that is greater than 2. If I plug in a negative 3, that's got to be negative to do this next part. 1, 0, doing the same numbers. And I try negative, I get 1, negative 3. That's going to be 9, that's 6. That's negative 18, that's negative 16. That's going to be 48, which is 43. Look at my signs. On the bottom row, the signs alternate. And because I tried a negative number and the signs alternated, negative 3 is a lower bound. There are no zeros less than negative 3. And it's like there were no zeros bigger than positive 2. All right, this one says factor this. We can't factor it if we don't know any zeros. So start out like we did yesterday. Let's make a list. The factors of 9 over the factors of 2, which is these. All right, and I'm going to try one. I'm going to guess really good again, just to keep the video fairly short. I'm going to try to guess really good. 2, 5. I'm trying 1. See what happens here. If I try the 1, I get 2, 2, 7, 7, -1, -1, -15, -15. See, it looked like for a minute there I didn't think it was going to work, but sure enough, it does. Okay, now, so I know 1 works. See if I can find something else from my list. Just to be fun here, let's try 3/2, just to be different. Try a little fraction here, see what we get. And remember, I'm trying my new numbers down here on the bottom, not trying the main thing, because I'm trying to condense what we started with. Bring down the 2. Everybody knows 3/2 times 2 is 3. That's 10. 3/2 of 10 is 15. That's 14. 3/2 of 14. That's a little tougher one. 21. That's 6. That's 9. Yes, perfect. So I know that's a 0. That's a 0. I need to find one more so I can get it down to a quadratic. Because if I can get down to a quadratic, I can just factor what's left. I don't know. Let's try something like, I don't know, maybe -1. Okay, let me make this a little smaller here so I have some room. Okay, so I'm going to try -1. And again, try that with the new numbers you have here, the 2, the 10, the 14, and the 6. Bring the 2 down. That's -2. That's 8. That's -8. That's 6. That's -6. Boom. Now, I have 2, 8, and 6. Once I get it down to that, 2x squared plus 8x plus 6, I'm going to try to factor that. Okay, so first thing I'm going to do is I'm going to divide everything by 2, make it a little easier for myself, like that. And if I factor that, I get x plus 3. Now remember, all I'm trying to do is factor this, x plus 3, x plus 1. So if I factor the whole entire thing, and because it's fifth here, I'm looking really for 5 factors. I'm going to get this. I'm going to get x plus 3. That's from there. I'm going to get x plus 1 squared, because that comes from there, and the one we found a second ago. 3/2 is really 3x plus 2, 3x minus 2. Think about slide, divide, slide there. And the very first one I found was 1. That would be x minus 1 when I run out of room again. I keep having to maneuver things here. X minus 1. And there it is. That right there is the factorization of that polynomial. That took a second. It's okay, though. And this last one right here, it says round to the nearest 10th. Find all the solutions round the nearest 10th. We're actually going to use some technology on this, so I'm going to wait and show you this one in class tomorrow. I know you hate that the video is going to be a little shorter not to do that, but I can't really put the calculator on here very effectively. So we'll wait till tomorrow, get the calculators out and show you how to do this last one, and I'll see you then.